So now we are going to look at two other techniques to answer such generic wildcard queries. Um, Again, just to remind you about the flow, what are we trying to do here? We are trying to answer wildcard queries. And what we have seen is that among the three possible dictionary implementations, it's the B tree implementation of a dictionary that can handle wildcard queries, right? So we are assuming, whenever we talk about wildcard queries, we'll be assuming a B tree. But now the two techniques that we're going to look at are going to be different from how we just answered the wildcard queries that we looked at. So this is how I want you to think about uh, the next solution. Okay. Remember that there will now be two inverted indexes. Okay. One of them will be the standard inverted index that we talked about. Could you switch off the microphone, please? I think I'm getting an echo. So we are going to work with the inverted index, the standard inverted index. But now we are going to have a second index, which is going to be a Permuterm index in the first solution, or the second solution. In the second solution, it's going to be called a K-gram index. Okay. These are two different indexes. I'm going to describe what they are. But what I want you to remember here is there are going to be two indexes. And I'm going to discuss the structure of this second index with you. Okay. So here's the second solution for answering wildcard queries, which are going to employ an extra index apart from the standard inverted index called the Permuterm index. Now let's see how this second index, which is the Permuterm index, is built. So when we create terms, okay, recall that pipeline, okay, where we collect the documents to be indexed, then we tokenize the documents, then we do linguistic pre-processing, and finally we use the indexer to sort the stream of normalized tokens, and we construct a dictionary and a postings list section of the entire inverted index. Now what we're going to do during that pipeline is, apart from doing, these particular steps that I just described, we are going to create a second index called a Permuterm index. And to create this Permuterm index, we will look at every term that goes into the standard inverted index. Okay, we're going to look at every term that goes into the standard inverted index, and we are going to create rotations of that term. Okay, what do I mean by a rotation? Well, firstly, I'm going to mark the end of this term by a $sign. So this $sign is a special character which tells us that this term ends at this particular $sign. And the reason for using this $sign is because now we're going to rotate this term. So when we rotate a term, we need to remember where the original term ended, and this character is going to mark that spot. Okay. So here's the first rotation. I can take this H and rotate it over here. So I'll get ELLO $H. I can perform another rotation of this string where I'll take this E and put it here. So I'll get LLO $HE. I can rotate it again, then I'll get LO $HEL. One more rotation will give me O $HELL. And another rotation will give me $HELLO. So these are all the rotations of the original string. Now each of these rotations, they're also called permutations in some way. Okay, each term, these are all permutations of this original term. So Permuterm just means permutation of the original term. And a permuterm index is going to have each of these rotated versions of the original term. Okay, so what we'll do is put these all into the dictionary part of the permuterm index. Okay, so these, I'm going to collect all these terms, all these rotated terms, and I'm going to do this for every term. Okay, every term in the original standard inverted index is going to be rotated in this way, and all of its rotations are going to be collected together, and they will be stored in the dictionary of the permuterm index. And the postings list of the permuterm index will have a single entry. So every postings list will have a single entry, and that entry is going to be, so let's take this particular term in the permuterm index. The postings list for this will be uh, uh, a single posting, and the posting will tell us what was the original term of which this is the rotated version. Okay, likewise, this term will also point to, I mean, you can imagine creating a separate posting entry for all the terms, or you can imagine all of them pointing uh, to the same node just to save space. So in this way, uh, every rotated version of a term in the dictionary is going to have a single postings list which will tell you what the original term was. Now let's see how we can use this permuterm index to answer various kinds of wildcard queries. So let's say the query is a string called x, right? So x is a string of one or more characters. It's not a single character, it's a string of one or more characters. So x is of course a normal query, and a normal query will be answered by treating it as x dollar, okay? Because we want all terms that basically uh, are of the form x. Okay, so we'll search for x dollar in the permuterm index, and of course, what will x dollar give us? It'll just give us x. Okay, x dollar here will be pointing to x. So in effect, we don't actually need to look up the permuterm index here. We just note that there is no wildcard operator here in this string. So if there is no wildcard operator, we don't have to look up the permuterm index, because we know that we are not going to get anything out of it. It will just give us x, and so we'll just go and look up the standard inverted index and search for all documents containing the string x. Now let's take a wildcard query like this, x star. How do we look up x star? Again, we will add a dollar sign at the end, okay, saying that we want all strings that start with x, and we are going to look up $x star in the permuterm index. Okay, so we will take this particular, so note that this is like a prefix query. This is like a prefix query exactly of the form that we were discussing a few minutes ago. And the other thing I want to point out is that the dictionary of the permuterm index can again be implemented as a B tree. Okay, except that now the strings have an extra character, which is this dollar sign. So you can define a particular ordering on the dollar sign. You can say that I'm going to treat the dollar sign as if in alphabetic order it appears right after the Z, something like that. You just need a well-defined ordering to create a B tree. So we can implement the dictionary of a permuterm index also as a B tree, just as we could implement the dictionary of a standard inverted index as a B tree. And in this dictionary of the permuterm index, we will search for $x star, and we will collect the terms. So what will we get when we look up the B tree? We will get all the terms which satisfy this particular query. and we'll look up the postings list for those terms. The postings list in the Permuterm index. And what will the postings list in the Permuterm index be? They will be all the terms in the original standard inverted index whose permutations were of this form, right? Which had permutations of this form. Okay, this may sound a little confusing when you look at it the first time. So let me go and also do a few more examples just so that you get used to what exactly is happening here. So let's take this particular wildcard query, because now you'll understand why. Because this particular wildcard query, this trailing wildcard query or a leading wildcard query, we could have answered them using the standard. We didn't need an extra index for that. So let's see how a Permuterm index helps over here. X star Y. So we're not going to use a second B tree now. We'll be using a Permuterm index now. There's no reverse B tree now. So X star Y, again we will mark it as X star Y dollar. Now any term which is of this particular form, X star Y, will have a rotation of the form YS X dollar, right? Because I can just take this Y dollar and rotate it here, or I could take this X, rotate it here, then take this star and then rotate it here. Sorry, this is Y dollar X star. Sorry. Okay, Y dollar X star. So any term of this form X star Y will have a rotated version of the form Y dollar X star. And any rotated term of this form will be present in the dictionary of the Permuterm index. And how do we search? So how do we search for all possible rotated terms of this form? Well, we can just look up the B tree, the normal B tree, because this is a prefix query, Y dollar X star. Right? Y and X are well-defined characters. You exactly know what they are, because the query is expressed as X wildcard Y. So we can take Y dollar X star, and Y dollar X is a well-defined prefix. We can look up the B tree of the Permuterm index over here, in the dictionary of the Permuterm index, and we'll get all the terms in the Permuterm index which begin with this prefix Y dollar X star. And for all those terms, we will look at the postings list for those terms in the Permuterm index. And what will the postings list contain? They will contain the original unrotated version of those corresponding terms, right? So they will contain terms of the form X star Y. For each Y dollar X star term that we get in the dictionary, the postings list will be pointing to X star Y. So by taking those postings lists, or taking the entries in those postings lists and collecting them together, we will end up with all the terms which satisfy this pattern. Now we can take all those terms, go into our standard inverted index, and look up the actual postings list containing the doc IDs for all those terms, and then take their union. And by that, we'll be able to answer this particular query. So if you got a little confused by this, just treat it as a special case of this query where X and Y is just the empty string. Right? So if Y is empty here, we'll get X star. If X is empty here, we'll get star Y or star X. It's the same. So try to understand how this generic wildcard query can be answered using a Permuterm index, and the other cases are just special cases of this. So once again, the way of answering this query is in a sequence of two steps. In the first step, we will be looking up the Permuterm index. In the second step, we will be looking up the standard inverted index. From the Permuterm index, we will come to know what are the terms that we need to consider. And we'll take those terms, look them up in the standard inverted index and take their union. Right? So the Permuterm index is telling us which terms satisfy this pattern. And then the standard inverted index will give us what are the documents which contain those terms. And how is the Permuterm index telling you how what terms have this particular pattern? Well, because you're looking up y dollar x star in the Permuterm index, and the postings list for all terms of this form will be terms of this form x star y. These will be present in the postings list. Okay, one entry for each in each postings list. Any questions about this? So here is an example. Right? So if x is HEL, y is O, this is the query is HEL star O. We will look up O dollar HEL star. Okay, we'll add this dollar sign over here, and then we'll rotate this in such a way that we get the wildcard at the very end. Right?
Excuse
So
me, sir.
yeah.
Sir, I just have a doubt. For this Permuterm index,
Mm-hmm.
sir, for each word we are rotating that word, and according to the dollar we're saving it like somewhere, right? For each term in the dictionary.
Yeah, so this dollar is present in every entry of the dictionary.
Yeah. So for like in a dictionary, there will be a lot, millions of words, and for each word we are going to rotate it like this, and we are going to
Yeah,
store it.
yeah, yeah.
So
So the
sir,
dictionary size is going to blow up. I mean, it's going to be pretty
yeah.
large.
So
Yeah.
in that case, can we? Is there any sort of overhead happening, like for
Yeah,
log?
definitely. So the overhead is there because um, that's the problem with wildcard queries, that if you want to answer wildcard queries, there will be a lot of overhead. And uh, I mean, look at this, for example. Um, Look at this particular wildcard query. It's again we'll just look at how we can answer this query using a Permuterm index, but there's going to be a lot of overhead, and that's unavoidable, because if you want to handle more and more sophisticated queries of the form x star and with wildcards and all, then you will need to do a lot of work on the IR system will need to do a lot of work. And that's actually the reason why if you go to search engines like Google and so on, they don't give you the option of an entirely free wildcard query. They do have wildcard queries in their advanced search, but those are more restricted kind of wildcard queries. You don't get totally generic wildcard queries of this form, because these queries take a huge amount of effort on the part of the system to answer, which is why they are available only in advanced search, and that too, only a restricted form of that.
Thank you, sir.
Sure. So how would we answer a double wildcard query like this? X star Y star Z. One way to answer this is, again, let's try doing the same thing. We'll add a dollar sign at the end. By the way, one thing I want to mention, if it wasn't obvious, how do we decide which rotation we want to go with? Basically, we want to push the wildcard operator at the right end. Okay, so if this was the query, we put a dollar sign over here, and then we take this Y dollar and rotate it to the left, so that we get the wildcard on the right side. And the result of that is that this will become a prefix query. Right? And a prefix query can be simply answered by looking up the B tree, the normal B tree. So we're going to try and convert our wildcard queries into prefix queries on the Permuterm index. Okay. So generic wildcard queries are converted first into prefix queries on the Permuterm index. The Permuterm index then returns a list of terms which satisfy the original pattern. And now if we know what are all the terms which satisfy the pattern, we can go and look up the postings list for all those terms and take their union. And we'll get all the documents which contain any of those terms. So in this case, we have two wildcard operators. So we can't push both of them at the end because we have this y in the middle. So what we'll do is, let's at least push one of them to the end. So let's take this z dollar and push it and rotate it to the left. So we'll get z dollar x followed by a star followed by a y followed by a star. Now what we can do here is we can just ignore the fact that this is star y star over here. Let's say that the query had just been a star. Right? In that case, we would have just had x star z, okay, which was the previous query, which we convert to z dollar x star. Now, when we get all the terms satisfying this query, z dollar x star, okay, we're going to treat this as a query z dollar x star, and we'll look up this prefix query in the Permuterm index, and we'll get a list of terms. Right, so we'll get a list of terms which basically satisfy this prefix query. And if you look up the postings list for those terms, we will get the unrotated versions of those terms, which will be terms of the form x star z. Okay, if you look at the postings lists in the Permuterm index. But actually our original query was x star y star z. But what we got was all terms of the form x star z. Now some of these terms will have a y in the middle. Some of them will not have a y in the middle. So what we can do is we can take this larger list and filter out the terms which don't have a y in the middle. Okay, or just choose the terms which have a y, pull them out, and then go and look up the standard inverted index only for those filtered terms. So to summarize, what a Permuterm index does is it allows you to handle wildcard queries.
Sir,
And yeah,
sir, can you please repeat that once again? That two wildcard queries.
yeah. So the two wildcards can be effectively collapsed into a single wildcard to start with. You just treat it as a query x wildcard z and get all the terms from the Permuterm index which satisfy this pattern x wildcard z. And the way you do that is just like we discussed over here. Once you have got all those terms, now you look at the fact that you didn't actually want a wildcard here. You wanted you wanted a y to be present in the middle between x and z. So you look at all the terms that you got from the Permuterm index and just just discard those terms which don't have a y in the middle. So you'll be left with all those terms which start with an x, end with a z, and do have a y in the middle. And these are the terms that you need to go and look up the standard inverted index using with. So the idea is not complicated. It's just like what we were doing here, except that we have this filtering step where we initially work with a simpler query, x wildcard z, and once we get the answer to that, we have this extra filtering step where we verify that we only choose those terms which have a y in the middle.
Yes, sir. It's clear.
Okay.
Thanks.
Okay, so this Permuterm query processing in general tries to take the original query which has the wildcard operator in it and transform it
Sir, excuse me.
Yeah.
Yeah,
Yes.
the previous slide, again, one more doubt in that previous.
Yeah.
Yeah, for solving this, suppose if we have more complicated queries with more stars.
Mm-hmm.
So is that filtering will be like going in levels, or do we have to put some substitution steps like star Z or star Y star, because we have solution in the previous examples. Star X star becomes X star.
Mm-hmm.
So is there a possibility of substituting that, like splitting the whole query, again substituting with the previous solution? Is there a possibility of that? Or do we have to follow only this method of filtering?
Well, there are other methods of filtering. So for example, you could say that I'm going to treat this query. I'm going to first do X wildcard Y, X star Y, and I'm going to do Y star Z. Okay, this is another way I could split this query. I could do it as X star Y and Y star Z. So I could calculate all the terms which start with an uh, which basically start with an X and have a Y, and I could start with sorry, I'll need to split it as X star Y star and star Y star Z. Yeah, this is a little more complicated. So maybe you can do this, but let's not worry about that here. If let's say you have a query like A star E star I star O star U. Okay, this is maybe an example of the kind of query you're talking about. What I was saying was that if you have a longer wildcard query where you have more than 2 or 3 wildcard operators, then you'll have to do pretty much what we did over here. You'll have to assume that the query was much simpler than this. It was just star. You answer A star U, and then you filter out all the terms which don't satisfy this intermediate portion. And that will give you the terms which satisfy the overall wildcard query. And then you can look up the documents for those terms and then take their union. So this is a wildcard query which contains all the vowels. Okay, all the vowels should be present in this particular order: A followed by E followed by I followed by O followed by U. So going forward, we the general way to solve a wildcard query using a Permuterm index is to rotate the wildcard to the rotate the query so that the wildcard operator gets pushed to the right, and then treat the resulting rotated query as a prefix query on the Permuterm index. So you can use the B-tree lookup now in the Permuterm index and get all the terms from the postings list of the Permuterm index which satisfy the pattern in the query. And then you go and look up the standard inverted index for those terms. Take all the documents that are returned for each of those terms and then take the union of all those lists. And as we just saw, adding this second Permuterm index is going to increase the size of your dictionary by a factor of 4, at least for English. This is an empirical observation. And that's because each of the terms is going to be rotated, and the rotated version of the terms is going to be stored in the Permuterm index. So the size is going to pretty much blow up proportional to how long the terms are. And on an average, the dictionary size goes up by a factor of 4, which this is the empirical observation for English documents.